Right. So in this today's topic, we're going to be looking at finance. So here's a question that we have here, right? Questions that are involving timelines. They are crucial questions that usually come up. Ne? What is most important is to know how do you deal with the timeline. Okay. Um, or rather, how do you actually even construct a timeline? We have Ted here who invest 10,000 rands into an account, right? And that account offers an interest rate of 3.25% per annum compounded quarterly. Okay, after 2 years, he deposits, right, an additional 2,500 into the account. 3 years later, withdraws 5,000. How much will he have in his account after 10 years? Right. So this is a very good question that is involving this one. There's no change in interest rate, but there's withdrawals, there's deposits, right? So how do you do it, right? The first thing that you need to do is to make at least a timeline to visualize what is actually going on there, right? Um, Now, what you must also be careful of is that this is compounded quarterly, okay? Remember the compounding period, ne? The compounding period, let me rewrite that table again that we should know in terms of compound interest, ne? If they say to you, right, so if they say compounded, right, compounded monthly, right, if they say compounded monthly, means that your M will be 12, right, meaning you're going to divide by the interest by 12, okay? And then if they say weekly, by 52. If they say quarterly, you're gonna divide interest by 4. If they say they also say what, daily, right, daily, that will be dividing by 365. And then if they say compounded half yearly, ne, compounded half yearly or semi-annually, right, then you're going to be adding interest 2 times in a year. So this M, good people, is just the number of times that you earn interest in a year, okay? This is how many times interest is added in a year. So if they are going to add interest to your money in every month, they're going to add that interest for 12 times in a year. So for you to understand this, I want you to imagine that you invest 500 rands into your bank account. Usually, at the end of the year, if you do this in January, at the end of the year in December, that's when you're going to get your 500 rands back. But you don't just get the 500 rands, you're going to get it plus what? Plus interest, including interest, But if it happens that maybe January, February, March, right? In January, you put your money in there, You put your money in January. In February, your money has already earned interest. So I'm just going to be putting I for interest. In March, right? In March, the money that you had here, right? Which is 500 plus the I, actually earn interest again. You see, it grows every month. We go to January, February, March, May, January, February, March, April, right? You go to April, the money that we had here, the balance here, earn interest. So that is monthly. Every month your money is accumulating interest. If you are going to be given interest weekly, it means you're going to get interest 52 times in a year. If it is quarterly, you're going to get interest 4 times in a year, because each quarter has 3 months, okay? Each quarter, it is how many? It is 3 months there. And then daily, imagine getting interest daily. That will be 365 times in a year. Then half yearly means 6 months. You get interest after every 6 months. So that is what a compounding period is all about. And this is why we now say the compound interest formula becomes like this. A is equals to P into 1 plus I to the power of, usually we say I over M to the power of N times M, right? Now recently, from the schools I've been working at, right, I've been asking them this particular question. I tell them, okay, suppose Joshua invest 600 rands into his FNB account, if the bank offers him 15.8% interest rate per annum, compounded monthly, how much does he have in 1.1 in 2 years, 1.2 in 48 months, 1.3 in 6 months, 1.4 in 20 years and 8 months. Right. So this is a question, right? Okay, let me be reading it because I know my handwriting is something else. Suppose Joshua invests 600 rands into his FNB account. If the bank offers him 15.8% interest rate per annum compounded monthly, how much does he have in 2 years, 48 months, 6 months, 20 years, and 8 months? Good people, remember here you're just using this formula here. So can we be very, very fast in terms of this, good people? What I mean is that can each question be at least 2 marks? Then we work on it as we go, right? Meaning that 2 marks, 2 minutes, like exactly 2 minutes, good people, not like in fact a minute. Okay, sharp. I'm just gonna give, so it means for these you're gonna need, let's do these two, so 4 minutes we do, and then another 4 minutes exactly. Today I want us to be strict in terms of time so that we cover a lot. Okay, so yeah, 4 minutes, which means according to my time here, it means at 13. Yeah, please, when you are done, just also raise your hand so that I see you're almost done or what. Mr. Liam, are you already done? So fast, minute. Raise your hand when you are done. All right, so I see you, ma'am. Thank you so much for that. I'm glad you are done there. So for the first one, so for the first one, right, great stuff there. Joshua invested that 600 into the account. The interest rate was this. Now, what I told people, I think in the last sessions, is that good people, whenever you see percent, just try to ensure that you convert it to decimal. So you would say here 15.8, then you're going to divide that by 100. Okay, so I think you should get the interest as 0.158. Okay, 0.158, and that is that is your interest there, right? Okay, and then 1.1, right? 1.1, right, for 2 years, right? The interest rate, how much will they have in 2 years? So A is equal to P into 1 plus I over M to the power of N times M, right? The interest, the P, the principal amount is 600, right? And then we have 1 plus, the interest is 0.158 divided by compounded monthly, right? So we're going to divide by 12 because it's monthly, remember. It's monthly, remember. So we say the number of years is 2. Then we want to know in 2 years how many months do we have, because if we say compounded monthly, we want to work in months only. So that's why we have to convert these 2 years to what? To months. So we're going to multiply that by 12. Then remember, you're going to say 600 into 1 plus 0.158 divided by 12, 24. So what is the answer that you get there? I had 821.28. Is this correct?
Yes, sir.
Thank you so much. So that's what you will have there. At least you will have earned himself some 221.828 interest there. Then second one, right? We already have the number of months, so there's no need of doing much. We just have to say 1 plus 0.158. You divide that by 12, then you say 48 here because it's already in months. So what do you get? They
1,124.18.
like this.
Yes, sir.
All right, great. Then 1.3, 6 months, right? So for 6 months, good people, I would say 0.158 divided by 12, and then 6 months we just put 6 there, right? How much does he have in 6 months?
648.99.
648. Great. So that is what you have. Now, what about 1.4? Can anyone maybe assist us in how they did 1.4? Or how they would do 1.4? Miss Ntivo, are you there?
Yes, I'm there, sir.
Okay, how did you do 1.4?
So for the years, for the I said 20 years multiplied by 12 plus 8.
So to get the number of months, right?
Yes, I said 20 multiplied by 12 plus 8.
Right. So what do you get?
But I get 248. 248.
Oh, 248 months. Are we okay? Should we continue?
I did it like that, so I said 600.
Mm-hmm.
I said 600.
Mm-hmm.
I said 600 in brackets 1 plus 0.158 divided by 12 to the power of 248.
Splendid. That's beautiful. Thank you so much, ma'am. Nice, nice, nice. So, what we would do there, right? This is perfect, right? That's what we would do definitely there. We say 1 plus 0.158, you divide by 12 into exponent 248 there, right? Wow, you'll have a lot of money, 15K, right? So 15,000, 381, 381, comma, yo okay 382. So that's how much you will have there. So if you invest 600, you get this interest in 20 years, you're gonna have yourself 15,000. Very nice, very nice. So yeah, that is how we deal with these things, so the question that I wanted us to do was this one. So Ted invests 10,000 into an account that offers the interest rate of 3.25% compounded quarterly. So if it says quarterly, now we know that we would be dividing the interest. We'll be dividing the interest by 4. Okay. And what was the interest? This is the interest here, good people. Remember, you turn it to decimal. It's gonna be 0.0325. Okay, that's your interest there. Right. Then he's doing some withdrawals. What there. Good people. I would like to say, since in most cases, right, since this is compounded quarterly, right, we can look at those years. It's fine. You can use years, but what I actually advise is that if it is compounded quarterly, when you say T0 here and then you say T1, T1 must represent 1 quarter, T2 must represent 2 quarters, okay? T3 will represent 3 quarters because you are working in quarters, But if you feel like that would be a bit too much, right? You can use years. So you want to know after 10 years how much you will have. You have 2 years. After 2 years, you did something there, so you just say T2, and then after 3 years, and 3 years later he did something, yeah, or 3 years later will mean 2 plus 3, which is what, T5, ne? T5. So all the time at the bottom we write the interest, good people. Interest did not change. The interest was 0,325, 0,0325. You divide that by 4. Right, then from here to there, right, he invested how much? He invested 10,000 rands, right? Then from there and then there, right? Then you're going to represent those deposits and withdrawals. There was a deposit, right? You can write it here as plus 2,500, which was 2 years later. Then 3 years later, right, which means 3 years later from those 2 years again, he had to withdraw 5,000. There was an emergency, so he withdraws 5,000 there. So how do we actually write or represent this, or what do we actually do there, right? You must be careful there, ne? You must be careful how you solve this. If you want to solve it the longer method, I will show you the longer method, then I will show you the shorter method, right? If you use a longer method, ne, you would have to say from T0 to T2, then you say A is equal to P into 1 plus I divided by M N times M, right? You can just write it as I and an N there, but be careful how you substitute. Principal amount was 1,000 rands, I get it. And then the interest there was 0,0325, then a quarterly, right? And then that was, it grew for 2 years, right? So you say 2 years multiplied by the quarters, which is 4. You want to know in 2 years how many quarters do I have. So that will mean 1,000 is going to grow for 2 years. We want to see how much will they have in those 8 quarters, right? So how much do you get here? I'm gonna try to be as yeah. 0,66.
1066,
Oh, nice. Comma 88. Yes, ma'am, you have a question?
the amount is not 1,000.
The principal is not 1,000.
Yes, sir, it's 10,000.
Oh, what did I? Oh, 10,000. Oh, Mudim. So sorry, good people, right? So actually, it is 10,000 there, right? Just wanted to check whether you were looking at that, right? That is okay. I see that you were looking at it, right? So it means here we're gonna put 10,000. Oh, so sorry for that. Oh, it means I'm missing just a 0. Hey, 1 0 can make a difference, eh? So 10,000, right? We have to put it as 10,000.
It will be 10,668,8788.
10,668,79, like this, right? Right. No, thank you so much. Now let's go, right? Okay. So let's go to T, from T2 to T5, ne? Let's go. T2 to T5, meaning from the 2nd year to the 5th year, right? You had A is equal to P into 1 plus I over M N times M there, right? Now, the principal amount there, good people, you must be careful now, eh? The principal amount now is this balance that he had plus the money that he put inside. He put 2,500, right? So we are now going to say the principal amount will be this amount plus the 2,500 he deposited there. So you say plus 2,500, you get how much? 13. You get 13,168 into 1 plus the interest is 0.0325. You divide that by 4, right? And then now you have yourself how many? 3 years. It's gonna grow again for 3 years, which is 3 multiplied by 4 quarters. Good people, to save time, I'm just gonna write it as 12 there. Right. So how much does he have at the end of the 5th year? $14,511.70. Okay, I think it should be this one. Yeah, should be this one, right? You can double check it for me there. Then we go to the remaining 5 years, né? So for the remaining 5 years, this balance there, you're gonna subtract 5,000 because he took out 5,000. I can remember that. So let me be writing this way. Remember that here I added 2,500, and then that is the one we used here. Okay, and then here I'm going to subtract how much? 5,000. So here we're going to subtract 5,000, and then that is the one that we'll use as the balance for this other year, right? Because that is how compound interest works. It works on the balance, right? So here we have T10, right? And then we're gonna say A into we take we'll subtract 5,000, right? It's now a lot. So you say 14,511,7 minus 5,000. You have yourself 9,511,7 into 1 plus 0,0325. You divide that by 4. For how many years? 5 times 4, which is 20 quarters, right? So how much does he have at the end of those 10 years? So you take that and you say 1 plus 0.0325. You divide that by 4, and then you say 20 there. Then you get what? 11,000. 11,182, right? 0.68. Imagine a person who had actually gotten around 14, now is at 11. Okay, but then here, I hope that is clear, right? Let me see. I hope that is clear. Let me see what you got there. Ma'am, when you were not done, Miss Sensation, eh? Miss Claudia, I hope you saw that you were not done. But then here, this is the correct thing there. Any question from there? Right. Now we're going to do it in a much faster way there. Now, I'm hoping we're gonna get the same answer. Eh? So if we use a much faster method, right, I'll just say alternatively, alternatively, you could say you just want to do this in one line. They used to tell us don't do this because one mistake you are gone, but then I trust you guys. So you say A is equal to, you're going to look at the amount he put first. It's 10,000. So you're going to say 10,000, and then let me write it here. It's going to be a long calculation, but let's try it. So it's a much faster method, right? So you're gonna say A, and then you're gonna say 10,000. Don't forget the zeros. Then you say 1 plus 0,0325. You're gonna divide that by 4. Then what you're gonna do for me, you're going to count how many years is 10,000 going to grow. 10,000 is going to grow for 10 years. If Mamela, listen to this carefully. 10,000 is going to grow for 10 years if we're just looking at it as if, it was not being disturbed. It was just on its own growing, So it's going to grow for 10 years, right? So when you say 10 multiplied by 4, you're going to get 40, to say 40 quarters there. Right, perfect. Then they added 2,000, so you just write it like it is. That's the nice thing about this one. You're just going to write yourself 2,500, right? Then you're going to say it's also going to stay in the bank and earn the very same interest, right? Like I said, it's going to be long on this side, but then it's going to earn interest for how many years? From T2 to T5, right? So it's going to earn interest from T2 all the way to the last end, as if it was not disturbed. You act as if the amounts are not disturbed at all. So it means you're gonna say for 8 years. So here you're going to say 8 years, which means you're gonna say 8 times 4. Then what did he do? He removed 5,000. You take it along with its sign, good people. So you're going to write there minus 5,000, and then that 5,000 also is going to be growing with the very same amount of interest over 4. Then you're just going to count for how many years? For 5 years, because it was for the remaining 5 years, right? So you're just simply going to say 5 multiplied by 4. Then when you put it in your calculator, just put the answers in terms of, don't put 10 times 4, you're going to get it wrong. Put it as 40. Here, put it here, right? So what is the final answer? So when you put it in your calculator, you're going to say 10,000, 1 plus 0,0325. Then you're going to divide that by 4. Then you're going to say exponent 40. Then plus 2,500. 1 plus 0,0325. Divide by 4. Then you're going to say 32 from A, 16.4, 32. Right. And then you're going to say minus 5,000 into 1 plus 0,0325, right? You divide that by 4, and then you're gonna say 5 times 4, which is 20. Perfect. So the answer that you get is going to be 11,182.68, right? Now let's compare with what we got. Perfect. Aish, abaname genius. Right, so that's what you get, good people. You see, I hope that it is clear there, right? So what you do simply is that you're going to act, you're going to act as if the 10,000, nothing is going to disturb it. It's going to grow for 10 years. Then the 2,500 that is added, you're going to act as if now it's going to grow for the remaining years. Then the minus 5,000, as minus as it is, it's going to grow for the remaining years. Then you're going to get how much he has at the end of. So I don't know which one you prefer. You can prefer this one, or you can go through it through the longer method there, whereby you're taking it step by step, ne? No one will penalize you. But is this clear, good people? Any question here? Are we not geniuses for that, good people? That's mathematics for you. You must find ways of dealing with problems, right? That's why I tell people you can't be a policeman without knowing maths. Never, 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 good people. You must know. All right, so this is what we have, right? I know the time there is going to kick us out, ne? Please do this one and see if you can get it. I have a nice one for you here. Right. Try it there. Sharpen your skills, good people. Yeah, what a good question. Okay, try this one, good people. I'm going to give you, let's see, I'm going to give you 6 minutes. 6 minutes, and then we look at it. All right, good people. So that was exactly 6 minutes. Um, right, very very nice question there. I hope you had very much fun solving it. X Rand is invested into an account, right, that is offering an interest rate of 12% per annum compounded monthly. So first of all, we need to convert this to decimal. So this will be 0.12. 3 years later, 2x rand is deposited. After 7 years, there is this amount. Determine the value of x. So let's maybe make a timeline to make sense of what is happening there, right? We have ourselves T0 to T7 because they said 3 years. After 7 years, meaning the total amount of years is 7, right? So here they're saying 3 years later, meaning at T3 around here. Obviously, this thing you can actually say T1, T2, and the likes. Then you focus on T0 and T3. The interest, did it change? The interest was the same. So the interest here was 0.12 divided by 12. Now for they invested how much? X rand, right? X rand. Can you say RX? And then 3 years later, what did they do? They deposited 2x rands, right, into the account. Now then it grew until that. Now at the end of the 7 years, right, we find that in the account there is a balance, the final balance of 27,655. Now this question you can do it, like I said, using the longer method or the shorter method. So I'm gonna use the shorter one because it's much faster. So what you can do, right, to find the accumulated amount, you are simply going to say, I'm gonna start with the first one. So you say x, then it's going to grow there, 0.12 into 12. For how many years? You are going to say it's going to grow for the whole 7 years. Okay. So we then say 7 multiplied by 12. And then you're going to say they added 2x rands. So you're going to say plus 2x. And then it's going to grow for how long? It's going to grow for the remaining 4 years, right? So you're going to say 12 times 4 there. Or 4 times 12. Same thing. Potato, right? Same thing. Right, and the accumulated amount was how much? The accumulated amount was 27,000. So you write it here, 27,655,87, right? So it becomes easier with this method, isn't it? So you then say, okay, now that we have this, now it's a matter of solving, right? So what you can simply do to make your life very, very, very easy, just gonna take x as a common factor. Then here you're going to be left with 1 plus 0.12 divided by 12. Now 7 times 12, 12, 24, 36, 48, 60, 72, 84, right? So it's 84 here, if I'm not mistaken. And then here you're going to have plus 2 into 1 plus 0.12 divided by 12. Now 12, 24, 36, 48. Here you have 48. Okay, then you have 27,655,87. Then you're gonna put this in your calculator, good people, right? If you put it quickly in your calculator, what you must get there is the following. You must get this is a nice question for a wow test. I'm gonna put it. Say calculate the value of x. Yeah, it's a very nice one. So you have 84, and then you have plus there, right? Plus 2 into 1 plus 0.12, you 12 divided by 12, right? Into 48 there. So you're gonna get 5,531 2, right? I'm gonna round off to 4 decimal digits because it's not the final answer, right? 87. So to then get x, you're gonna divide both sides by 5,5312 divided by 5,5312. Then from there they will cancel and then you'll get your x. So you get your x as 27,655,87 divided by the answer there. Yeah, so you get 5,000 rands. Exactly 5,000 rands. Right. So that will be the amount that was invested there. Great stuff. You know when you've eaten food, do you know that you cannot talk for a long time? Yo. Yes. But then let me send them the link. Right, send them the link there. Then we can have our second session, right? Like that. We're not getting the same amount here. What did ma'am do here? Think I said 4. What did I say? 4 and 3. Yo, I made a mistake. Yo, Mutim. Aish. Yo, good people, I see that I made a mistake there. Aish. So here it's, thank you so much, Miss Ntiri. It's 3 years here. It's 3 years, not 7. I don't know where I got 7, to be honest with you guys. I don't know where I got 7. It's actually 3 years here. 3. Right, 3. So it means 3 times 36 here. Yo, messed up my calculations. Let me share the screen. Yeah, sorry for that. So I'm saying here it was actually 3 years. I don't know where I got the 7 years from. Here, good people, it was 3 years. You see, I wrote it in green because I was fixing it now there. I'm only seeing it after ma'am showed me. Evan, this thing doesn't want to do undo now. Oh, it can do. Right, so yeah, it's 3 years here, good people. So 12, 24, 36, it means here is not 84. It's actually 36 there. It's actually 36 there. And then from there here, I think it will affect the final answer now. Oh my goodness. So I should put 36 instead of putting what I did there. Oh yeah, I can edit at least. Yes, I can edit. So I say here is 36. Yeah, I get 3,000. Right. The correct one now. So let's remove this part. Right. We get around 3,000. Or does it already give me the answer? Okay, 3,000. Please do confirm. 3,497, 8,486. Then you're not gonna round off. You're gonna round off to 3 decimal digits because it's not the final one. 8,486, 3,497, 8,486. Therefore your x will be equal to, so what you will do, say 27 now, 655,87, you divide by the answer, then you are to get hi, what's happening here, good people? This one is not giving me What is the answer that you get? Let me see what you got here. Let me see what Miss Study got there. Miss Study, you got 5,000. Hey, banna. 5,940. Am I making a mistake somewhere there, or is my substitution? It is 36 months there. 36 months. 2 into 1 plus 0.12. I can no longer hear your mic, ma'am. It's now low again. Oh, it's 4,000 inside there. Yeah. How many times am I gonna read? If this was a book, I would be in trouble. So this is 4,000. Oh, 4,6552. Yeah, it was my calculator. Then you divide by the same thing. 4,6552. 4,6552. They cancel each other. Then we solve for that x rands. 27,655,87 divided by the answer. Then you get 5,940,83. Yeah, it was my calculator, good people. Sorry for that. So that is how we solve it there, right? As you can see, this method, good people, is much faster and more efficient. So don't forget it there. Any question from there? All right, so what we are saying, right, is that when you have a timeline, you just have to look at the total amount of years we are dealing with, right? Because here they invested X rands, right? They invest X rands into an account. So here we are starting with X rands. Remember I said T0 is the bank. You invest X rands. The X rand is going to grow for the 7 years. Okay, they said 3 years later, he deposit 2x rands, so meaning it's plus 2x into that account 3 years later. Then they say after 7 years there is 27,655.87 in the account. After 7 years, they didn't say 7 years later. You see, if they had said here, right, if here they had said 7 years later, that will mean that you have to say 3 plus 7 years. Okay, so it means that we'll move from 3 here, and then here it will be T10. Okay, that is after 7 years. But they actually said 7 years later to say from the beginning to the end. That is 7 years later from the time he invested his in his account. So 7 years, after 7 years, the total balance is this one, 27,655,87. That is what is in the account. So how do you solve it? The interest was not changing, right? So how do you solve it? All you have to do is to say the X was in the bank for how long? The X was in the bank for 7 years. What about this 2x? It was in the bank for how long? It was in the bank for 7 minus 3. Wait. I was right. When I Misintisha made me erase my correct stuff there. I was right. Hi. You see, Misintisha, we're gonna fight. I'm not gonna write it again. Let me just do a lot of undo there. Why did you say 3 years there? Because it's not 3 years. What I said to you is that you're going to say the X is going to grow for the whole 7 years. The 2X is going to grow for the whole 4 years. And then after that, you get your answer. But when you said the X grow for 3 years, and then these 2X grow for 4 years, that is not correct, that one. It's not correct. It must be for the X stayed in the bank for 7 years. It didn't stay in the bank for 3 years. Yeah, ask. Yeah, I was right. This was correct, good people. It's 5,000 rands. Yes, Miss Ntiro, do you understand me?
Yes, I understand.
You can check from the previous question here that we did. I said to you, the 10,000, you're going to look at how long does it stay in the bank. The 10,000 is going to stay for the 10 years. The 2,500 is going to stay for 8 years. The minus 5,000 is going to stay for 5 years. That's what we said. 10 years, 8 years, 5 years. Okay? So, if you want to say that the 10,000 stayed for 2 years, then you must use this longer method whereby I'm saying 2 years, the 2,000, the plus 2,500, and this 10,000 stayed for how much? It stayed for 3 years. That's when you're going to say here 4 times 3, here 4 times 3, and then you want to say this is then grows for the remaining 5 years. That would be 5 times 4. So this one is the longer method. The shorter method is to look at this and say it stayed for the whole 10 years. Is to look at this and say it stayed for the whole 8 years. This stayed for the whole 5 years. So let's be careful there, ma'am. I'm only realizing it now when ma'am Divo says I must re-explain. Okay, so we must know that you take this money and say how long did it stay in the bank. It stayed for 7 years. Assume it was not disturbed, nothing was added, nothing was subtracted. Okay, and then you look at this one. How long did it stay in the bank? It stayed for the remaining 4 years. Then that's why we have this 4, that's why we have this 7 there, to say the X stayed for 7 years. Then you get your answer. Is it clear? Miss Ntivo, are you okay now?
Yes, sir.
Oh, okay, great stuff. Yeah, great stuff. So those are some of the quite interesting questions there in finance. That was 7, 8. Okay, this one is fine. You know how to do that one. Right. Then we were here. Future value. Ne? I want to show you how future value relates to what we actually did just now. Ne? I want you to see something here. I want you to see it. Perfect. I had put these things in order for a reason. So check. Future value, good people. These are used when a certain amount of money, please listen to the English. A certain amount of money is placed into an account on a what? On a regular basis in order to save money. Okay, you usually do it to save money on a regular basis. Good people, it says a certain amount of money is placed into an account on a what? On a regular basis. On a what? On a regular basis. What does regular basis mean? This means, okay, what does a regular basis mean? Maybe let me hear from you guys. Anyone who can tell us, what do I mean by regular basis? Or what do you understand by regular basis? Yes, Miss Ntevo. What are you saying, Miss Ntevo? Every now and then. Are you doing English as home language or as first? I did it as first additional, so sometimes it kills me. But if you're doing it as home, you must know what does regular basis mean, Miss Ntivo, I will say we're doing FAL, both of us. Consecutively. Yo. Consecutively. Hey, good people. You see, your English must be good. I told you. Yeah,
Regular basis, no?
yeah.
It's like a pattern.
A what?
Like the patterns are like in a month in this specific day that you put. It's called the regular day for the years that you're going to okay. But regular basis it's an interval, time interval, something there. So
Interval, time
yeah.
interval. Okay. By the term, when you put time, I think I will agree with you with time there to say there is a bit of time involved. Mm, there's a bit of time involved. But I'm worried, Miss Cindy, for that. If a grade 6 learner can come to you and ask you, Sisi, can you assist me? They said I must explain what is a regular basis. And then you say to the grade 6 learner, time interval. I'm worried you might not understand what you mean. What you mean. Right, good people. So regular basis, ne? This means, yo, I only know it in Sesotho, but then let me try to put it in English. But how can we interpret English, good people? It's a regular basis. It must be regular basis. The way you should understand it is that this thing you're doing it on a regular basis. Okay, so that's what you must understand. You're doing it on a regular basis, which means if you are going to be putting that money every month, month after month, then you're going to be doing it every month. That means that is regular basis. Month after every month, after every month, after every month, it's a regular base. If you're going to choose to do it weekly, it means after every week you're going to be putting in that money. Meaning after the first week you put the money, the second week you put the money, third week. And good people, when they say a certain amount, that money does not change. You're always going to be putting the same amount of money. So it means if at the end of January you put in 300, at the end of February you're going to put in 300. You're going to the bank yourself. Here you are, you're going to the bank. Every month you're taking how much? Every month you're taking 300 to the bank. Right? Every month. Whether you are sick, whether you are tired, whether you just got married, every month you are taking in 300 to the bank. That is called a regular payment. Right. So if you're doing it every year, you're going to be doing it every year. If you're doing it after every 3 months, then you have to make sure that you're consistent. Here we are talking about consistency. Someone said consecutively. Okay, let me say consistently. I think that one is much at least mathematical nyana. Consistently, you are putting in money consistently for the same time interval, like Miss Devo said. So the time interval must be the same. If it's weekly, monthly, daily, you are doing it consistently. So the future value calculations are going to be for retirement annuities, right? It's also called future value annuity, by the way. It's called future value annuity. What is an annuity? Annuity is an amount. Okay, annuity is when we are talking about either money that is it has to do with regular basis. Annuity has to do with regular basis, right? We are talking about money that is either deposited on a regular basis or money that is being removed on a regular basis. That's annuity there. So future value for retirement annuities. If you want to retire, this is what you do. You're going to say every month, right? That is what in fact you're not going to be the one who is going to do it. If you are earning a salary of 16, okay, I know you're gonna earn big salaries. Let me say if you are earning a salary of 85,000 rands and you decide to say I'm an independent woman. I don't need a man in my life, right? So you can then understand that you are not actually getting 85,000 in your account, okay? You are actually getting more than 85. If your salary is 85,000, you're getting more. Where is the money? Where is the more going? Your employer, maybe you're actually earning 90,000 and you are not aware. What your employer is doing is that they're taking the 5,000 every month. They're taking the 5,000 and depositing it into your own savings account. Okay? They're depositing it into your own savings account there. Right? So every month they're putting in the 5,000 into your account there that you don't know where that account is. When you retire, they then give you that 5,000. So that is an annuity, and you are doing it so that when you retire, you have a lot of money. It's a smart way of saving for you, because they know if they give you 90,000, you need pedicure, manicure, I don't know what other cures, right? But you need all of them, and then you won't save anything. Savings account, we also do it for savings account, right? Whereby equal deposits are made at regular set intervals, because savings account could be that sometimes when I have 5,000 I'm saving 5,000, when I have 100 I'm saving 100, you see now. But the savings account we're going to be talking about is whereby you are making equal deposits every month, maybe every week. You're depositing the same amount to the bank at regular intervals. And then sinking funds. Sinking funds, we said this one we discussed it to say you are saving up money so that you'll be able to afford to buy either a new machine or a new equipment that you are using now that you're gonna sell in future. Okay, so let's look at it, good people, right? Why am I saying that I'm happy that it actually popped up? It's because I want you to look at this timeline, right? We have January to December, right? January to what? To December. Equal payments of 500 are made into a savings account at the end of every month for 1 year. You see now you're being consistent. Every month you are making a deposit of how much? Of 500. So here you are, January, month end, you deposit 500. February, you deposit 500, month end. 31st of March, you deposit 500. You are doing that every month. So that is an annuity. Here, man. Here, man. Okay, let's finish off. So now, if the account offers an interest of 5.5% per annum compounded monthly, how much will the accumulated in the account be after 1 year? Anger. So how you would solve this, good people? Remember, you can decide to be Miss Clady and say, okay, you know what? I'm gonna deposit 500. So I'm gonna look at 31st of Jan, 31st of Jan to 28th of Feb. Then you're going to use your compound interest formula and say, okay, we're gonna deposit 500, right? And then it's going to grow. The interest is going to be 5.5. Oh, remember, we changed that. Hey, don't make a mistake, eh? You change this to decimal. So it will be 0.055. So here you're gonna put 0.055. Since they said it is compounded monthly, right? Compounded monthly. So what we will do there is that we're going to divide the interest by 12. Then remember, good people, it's just 1 month, eh? From January to February, it's just 1 month. So there's no need to say 12 times anything. Just put the number of months. That is why when we started with you, that is why these things are going in sequence. That's why when we started, we did this question, whereby it was compounded monthly. When I said 48 months, we just substituted 48. Do you remember? When I said for 6 months, you just substituted 6 months. When I said 20 years and that months, you got the number of months and then you substituted the months. So now on this question here, right, that is the same thing you would do. You want to grow the 500 you deposited at the end of January. You want to grow it for 1 month to February. Then you're going to put it in your calculator. How much do you get? Yeah, you get 502 comma 29. Sure, it means in 1 month you have earned 2 rands. It's better than nothing. Then you go from February to March. So on February to March, what happened? You deposited another 500. I get it. So what should you do? You should say, when you go for the 28th of Feb, ne, for the 28th of Feb all the way to the 31st of March. 31st of March, ne? You should say A is equal to, you must take this money, then you must add 500 because we deposited 500 again. So you must add 500 there before you can put it here. So you say plus 500, then you're gonna put it as 1000 now. 1002.29. Then it's also going to grow for 1 month from February to March. I get, you say 1 plus 0.055 by 12. It's gonna grow for 1 month. Then you're gonna get your answer. Good people, we are not gonna finish here, but let me just show you this one first, and then we are done. Then you say 1 plus 0.055 divided by 12. So you're gonna get 1006.88. This is from February to March. That is the balance at the end of the month of March. You have 1000. So this is the balance. I'm gonna write it. Balance at the end of March. Then what do? You deposit another 500. So when you grow this money from March to April, you are now going to say this balance you had at the end of March plus the 500. Then you're gonna grow it to April. Good people, imagine doing this until December. I think you can agree with me that it's very tiring, eh? So that is why we use the future value formula. That's why we use this formula here, because it's very tiring, good people. So you're gonna say this one, I think it's minus 1, all divided by I. So you use this formula whereby there are regular payments. Remember, there are regular payments or payments made on a regular basis. So when there are regular payments, another thing is that when there is when we're talking about the retirement funds, right? Retirement funds, right? Oh, sorry.
Disconnected.
Here, man. Okay, retirement funds, and then when we're talking about
Connected.
skis, sinking funds. So this is the formula we use, good people, and this formula comes from the fact that it's actually a geometric series, but I think if you can go to the last video, you'll understand that much better. Okay, so but this is what we that's why we use this formula, because now we can do it manually, but it will take us a long time because it's an exhausting, in maths they say it's a daunting calculation, right? So how it works, right, is that the 500 is going to grow for the whole 12 months, the other 500 is going to grow for 11 months, the other one is going to grow for 10, right? Like that. Then it becomes a geometric series that you can actually solve there. If you were following along when we were doing these timelines here, then this question here, how it's derived, the formula how it's derived, will make much sense to you, because we're actually saying, right, I like his derivation a lot, so sorry for showing you, good people. I know I'm wasting your time, but Mamela, it's good to understand, right? So the 500 here, ne? What you do is that you think of this 500 to say, oh, it's going to grow for how many months? It's going to grow for the 12 months. So it means you're gonna say 500 into remember using this formula, right? 500 into 1 plus 0,055 divided by 12. It's gonna grow for 12 months, right? Then you say plus this 500 in February, it's gonna grow for 11 months. So you say 500 again, right? It's gonna grow for 11 months. Ne? After that, you then say this one that is deposited in March, it's gonna grow for the remaining of the months. How many months? It's gonna grow for 10 months, right? So you say 500, it's gonna grow for 10 months, right? Like that, like that, like that, until the last 500 that you are depositing on December. Is that one going to grow? That one is not going to grow, good people, for any month. So it will just be 500, but we can write it to say that one is going to grow for 0 months because you're depositing it on the last day. I get it. So it's not going to grow. So you're just gonna say to the power of 0. Good people, if you can look at this thing and reverse it, write it in reverse. It means you can write it as this one. You can start with this one. Remember, anything to the power of 0 is 1, right? So you can write it as 500 plus 500 into 1 plus 0,055 divided by 12 to the power of 1. And here now you are writing it in reverse. Then you do the same thing to the power of 2, right? You do the same thing to the power of 2. Okay, like that, like that, like that. You do it like that, and like that. Right, so once you have it like this, then you say plus again. You're going to continue that until the last amount. Remember, you are writing it in reverse, so the last amount will be 500 there. So it means that you will say 500, and then you say 1 plus 0,055 divided by 12 to the power of 12, right? And then from there, you can think of it as now as a geometric series, because the value of A is 1. The ratio is actually this. You divide it by that. T2 divided by T1. Okay, you say 500, 1 plus 0,055 to the power of 12, exponent 1, you divide it by 500. The answer that you get there is 1 plus 0,055 divided by 12. Why? This is because this will cancel that. So this is your ratio, your R. Yeah, remember T2 divided by T1 is gonna give you R. And get, or you can even try by saying this divided by that. Good people, you are still going to get this R. Then remember, the sum of geometric says A into R to the power n minus 1, all divided by R minus 1. So the sum of n, right? Sum of n is going to be what? It's going to be, oh yeah, so the first one is 500, and then the R there, right? Remember R, we calculated it, right? So I will say R is 1 plus 0,055, you divide it by 12 to the power of n, right? N will be how many months in total. So in total it's 12 months. And then you divide by, so it's the 12 payments that you made again, and then you divide it by R. Remember, this is your R, which is 1 plus 0,055 divided by 12. Remember there is a minus 1. So what happens at the bottom there is that this will cancel that. Okay. And by the way, sum of n is going to be the accumulated amount. Okay. It's going to be the accumulated amount. Right. So you then have yourself accumulated amount as 500 into 1 plus 0,055 divided by 12. My board is very slow today. I'm very sorry. Could have finished this much faster. Divided by 0,055 over 12. Good people, if you're with me up to so far, congratulations, because now you have differentiated yourself from many grade 12s out there. Because now this A, we now call it future value, because it is the money you get after some time of making regular payments. This amount, remember, is the money we're depositing every month. Do you still remember? It's the money we're depositing every month. I get. So that money there, we call it X. Okay. Then you have 1 plus. Here, good people, is your interest. Remember, your interest will be divided by the compounding period. And then here is going to be the number of months. So we can call it n times m minus 1. And then we say down there is also going to be interest over m. So usually this interest over m, they don't write it. Okay, they don't write it. So the formula just become like this. F will be equal to x 1 plus I to the power n minus 1 all over I. Bravo. Let's celebrate. Bravo. Right. Now you are very bright. You are learned. Now you know that you don't just take things as they are. You actually know where they come from. That is where the future value formula comes from there. It comes from the fact that if money is deposited every month, so you take the first one to say it's going to grow for 12 months, the second is going to grow for 11 months, the third is going to grow for 10 months, like that. The last one is not going to grow. And then from there, you think of it as a geometric series, and then you can actually find A and R. Then you have your formula there. Then that's where the future value comes from. Any question? Did we understand it, good people? I'd actually want you guys to confirm whether you understood this. Did you understand it? Miss Intivo, did I lose you at any point? Ah, nice. Miss Ladi, did you get it fully? Ah, perfect. Ah, good people. You are mathematicians now. I promise you. You can even prove this to your teachers. Mr. Liema, it's like you're doing disappearing, appearing. I'm not sure if you were with us, Minere. Were you with us?
I don't know. But tomorrow.
Okay. No problem, Minere. Here we're actually building mathematicians. So good people, from this, if I tell you any question in sinking for sinking funds, it means that will need future value. It means from the get-go, you are not going to struggle because you know where the formula comes from. I can tell you that Andile deposits 600 rands every month into his account. The interest there that he gets is 6.8% per annum compounded monthly. I give you a question like this because there is this word every month. Then you must remember what? Regular basis. Okay? Then therefore it means we have to look for the future value. Future value is just the accumulated amount after a certain number of years. So we're going to say how much will he have, right? How much will he have 60 years from now? right? Then you know, because they said every month, it's a regular basis question. So we have to use future value there, right? You have to use future value there. You write it exactly the way it is. Now you know to say, oh, X is the amount of money I'm depositing every month, 600. Ne? Then you're like 1 plus. Oh, the interest, I must get it into decimal first. Okay, so I'll write it as 0,0068. I write it there, 0,068. It's compounded monthly. Oh, I must divide by 12. How many months was that? You say, 60 years. Wait a minute. I don't know how many months is 60 years. I'll just say 60 multiplied by 12. And you know what Mr. Clayton said? He said, don't put it like this in the calculator. Calculate it first, right? Or else you're going to get wrong answers. Then you divide by the interest again. Oh, the interest, I must still divide it by the compounding period. Then you know you're going to get your future value. Right. So you don't just use it, but you know where it comes from. What's going on there. Deep ends. So it means we're giving you all the things, the thinking. It means also, wait, I don't know if I'm getting way ahead of myself. You know, when you talk maths, good people, understand this also. Now you can understand that if I set up a sinking fund, what am I trying to achieve? Understand that in a sinking fund, 2 things are happening. There is inflation happening, and then there is an annuity going on, a regular saving. Why? Suppose that you buy, let's just put a laptop here, right? So here you are. Yeah. So here you are. You have yourself an Apple laptop there, right? Right. Well, it's called what? iLaptop. I'm not sure. But let's just say you have your Apple laptop there. And then today in 2024, the laptop cost 7,500. Sorry, that is the cost. We are happy we are able to buy it. Let's understand that 2 things are going to happen. The very same laptop, in around 2028, or maybe let's just say around 2032, is the laptop, right? Let's understand this. Is the laptop in the shop? In the shop, there are 2 things that are happening. The laptop in the shop is not longer going to cost 7,500. It's going to cost more because of inflation. So let me write this. Cost more. Let's write it. Cost more because of what? Because of inflation. Let's just say that the inflation rate was around 18% per annum. Understand this, good people. To buy the very same laptop, it's going to cost you more, okay, because of inflation. So that is the same thing as saying to buy bread. We used to buy bread, Sasco bread. We used to buy it at 8 rands, but today Sasco bread is around 19 rand. But did they change the taste of Sasco? they didn't change it. It is still the very same SAS code, just that now it costs more. That means money has lost value. So in terms of inflation, let's understand that here money lost value. It's not the computer that lost. Okay, yeah, money lost value. So that is why the laptop is going to cost more. Ne? So the laptop is gonna cost more. So let's calculate. What formula are you going to use to calculate how much is the cost of the laptop? Right? So the calculations, we can put them on top here. Because it's inflation, you're gonna use the formula for compound interest. Ne? And then you're going to say the principal amount, meaning the original cost was 7,500. Ne? The interest was 18% per annum. That one you can just write it as 0.18. You don't have to divide it by n, because you don't have to divide it by anything, ne? Because you just divide it by 1. Inflation happens once in a year. Okay, it doesn't happen a lot of times. Well, hypothetically, so we're dealing with hypothetical. From 2024 2032, 2032 is 6 plus 2, it's 8 years. Good people, can someone tell me what is the cost of the laptop in 2032 in a shop? Yo, I hope you're not sleeping. Ask keys, guys, you know what? Ask keys. So it's 28,000, ne? 28,191.44. So this is the new cost in the shop, ne? In the shop, it now cost so let me write it here. Okay. It now costs 28,191.44. But another thing is happening again. Since I'm the one using it, right? So because of my usage, it's going to cost less. Ne? Why? Because of my usage. Right. So here when we're talking about it costing less, we're saying that the value of the laptop decrease, meaning it's gonna depreciate there. Right. The value of the laptop is gonna decrease, meaning that it's going to depreciate, it's going to lose value. So because of that, the new cost, now I have to know what is the depreciation rate. They can say maybe it was depreciating at maybe 6% per annum compound interest, reducing balance. So it means that here we're talking about depreciation. So the calculation for that, so it means the laptop now, the cost of the laptop, I'm using the used one. So you can put it here and say the cost of this laptop, the used one. Ne? How would you calculate it? You would say, okay, A is cost to P into 1 minus I to the power of N. Right? You say it used to cost 7,500 and then 1 minus 0.06 to the power of 8. Right? Then you're going to calculate now how much is its value, because I've used it. I get it. Because I've used it, then you would get 8, I think, or 4,571. 4,571.77. This is the cost because I used it. So now you are going to say, okay, this is the money now that you're going to sell it at. Ne? So when you are going to sell it at this price in 2032, you're going to sell it at this price, 4,571. And when you sell it at this price, because you want to buy a new one in the shop, you're going to sell it at this price. So the money that you're going to get after selling it is not going to be enough to buy this one, right? So after selling it, the money that you're going to have, right? So let's just write after selling, the money you would have is going to be 28,191.44 minus the one you sold it at. So it means that the balance, or rather the answer there, 28,191.44 minus the answer, you get yourself 23. So this is the money you are still left with so that you can buy that laptop. So because of this shortage, we call it a shortfall. Call it a shortfall. This is the money that you are going to save up in your sinking fund. So hence there you are going to use the formula for future value, right? I think now you know it. So for this one here, this is the future value that you want. Then when you're going to be calculating how much money must you be saving up monthly to achieve that amount, then that is how sinking funds work. Askisi, I know that was a lot, but I just wanted to give you a clear picture of what is going on, Right, so Miss Intivo, I hope sinking funds are clear, When you go there at school, it's always, I think, around a 6-mark question. At least when they are saying a lot of stories there, you know what is happening. Inflation caused the thing to cost more in the shop, while depreciation, because you're using it, costs now the laptop to be less value. When you're selling that laptop, you're going to need more money, a shortfall, to cover, or rather to buy a new one. So that is the money you are saving in your sinking account. Is it clear, ma'am? Right. No. So in that case, let me see you guys tomorrow, right? We'll continue this tomorrow, good people. And then finish with finance there. I'll get more and more questions that we were going to do, but they take time, but yeah, we'll do them tomorrow. Have a good night.